Is this your first AP exam? Don't worry. This AP Live Review will give you all the tips you need to do well on the AP CS Principles multiple choice portion of the exam. I'm Mrs. Julia Lano, and I teach at Hamilton Southeastern High School in Fishers, Indiana. And here is your first AP Daily Live Review. So, what will we learn today? Let's take a look. In this video, we will discuss the exam details and review Big Idea 1, which is creative development. The topics we'll cover are those exam details, and in Big Idea 1, the topics are collaboration, program function and purpose, program design and development, and identifying and correcting errors. So those will be the topics that the questions we see will be over today. The skills covered in today's lesson are investigate the situation, context, or task, determine and design an appropriate method or approach to achieve the purpose, explain how collaboration affects the development of a solution, explain how a code segment or program functions,
and identify and correct errors in algorithms and programming, including error discovery through testing. So we are going to take a look at all those things kind of wrapped up all in one in the review we do today. So here's how it's going to play out. We'll do the exam overview first. We'll review some vocab, some essential knowledge from the year, and then we'll see some example multiple choice questions before we practice them on your own. And then we'll also have a Create PT tip of the day, since you should be wrapping that up and turning it in soon. First off, let's do a little warm up. So we're going to dig into the vocab and essential knowledge here. So exam overview. So first off, you have two sections to the exam, as we just mentioned, the create performance task. So hopefully you've spent your 12 hours on that about now, or you're wrapping that up. And we are really going to focus on the multiple choice. So there are 70 multiple choice questions. You have 120 minutes to do those 70 multiple choice questions. There are 57 single select. There are 5 single select that go with a passage. And then there are 8 multiple select. So you will select 2 answers for those questions. So 120 minutes, so 2 hours for 70 multiple choice questions is what you'll have for the multiple choice exam. Here, it gives you a breakdown of about how much percent each of the big ideas count on this multiple choice. So the 5 big ideas are creative development, data, algorithms and programming, computer systems and networks, and impact of computing. So today, as we said, we're focusing on the first one, which is creative development. So you see it is 10 to 13% of the exam weighting. So you can find this all on the College Board website, but here is kind of a detailed layout. For the exam, you get to use the exam reference sheet, but it's actually more than a sheet. It's actually a whole kind of few pages or packet. So you see here, kind of scrolling through it for you right now, so you can see the layout. So this is the AP pseudocode. All the questions about coding will be using this AP pseudocode language. The test is called language agnostic. So you may have learned JavaScript or Scratch or Python. So students from all over the world, and you can use any language to cover the concepts in this course. So for the exam, we have this AP pseudocode because that way we can all use the same language here. And so this exam reference sheet is very important for you to know and work with a little bit before we start, before you take the exam, so you understand what the questions will look like and how that code works. So we will review this and go through, use the exam reference sheet throughout this AP live review sessions so that you get familiar with it, and we will use it on the questions where it's needed. So again, any coding questions will use this block code, or it may be text, but it is this AP pseudocode that's all laid out on this exam reference sheet. Again, there's a link there, shows you where it's available, but it's available on the exam site. Just take a look and you can find the APCS Principles exam reference sheet. Next up, here we are, a little bit more about the multiple choice and the computational thinking practices. So this breaks down the percentages of weighting on the exam of the computational thinking practices. And again, we have 5 computational thinking practices. Computational thinking practice 6 is assessed on the is not assessed on the multiple choice. So you see the 5 here. So solution design, algorithms and program development, abstraction and program development, code analysis, and computing innovations. So you see about how much percentage there. We're using a lot of those practices today, and that can help you know how you're prepared. All right, the exam, that's what's coming up soon. Monday, May 9th. It will be at 12 p.m. local time and done on paper at your school. So keep that date. Make sure, I'm sure you know it already, but coming up real soon. So there's your date and noon time. So make sure you eat breakfast and lunch and be all prepared for the exam. Only 2 hours. Most AP exams are 3, so this one's a little shorter. Again, no problem to get those 70 multiple choice questions done in that time. All right, let's review. We're going to take a look at a few review multiple choice questions first before I give you a chance to practice on your own. Oh, review some essential knowledge. So first, essential knowledge, computing innovation. So a computing innovation includes a program as an integral part of its function. So when we talk about a computing innovation in a problem, this is what we're talking about. So it doesn't have to be something that's like brand new, but a computing innovation has a program as an integral part of how it works. So a self-driving car or an app that you're using is a computing innovation. A computing innovation, there it is, can be physical or non-physical. Also, a concept like e-commerce, something we all do every day, shop online, e-commerce. So those are computing innovations. A program is a collection of program statements that performs a specific task when run by a computer. A program is often referred to as software. So you've probably made some programs at this point, and so just making sure to review that terminology. You will see a ton of the next one, code segment.
A code segment is just a little collection of program statements, and you've probably worked already with your create task on cutting code segments for your written responses. You will often see small code segments on multiple choice questions where you have to analyze those. So it's just a little portion of a program code. Some other essential knowledge, program documentation is written description of the function of a code segment, event, procedure, or program and how it was developed. So oftentimes a program language, you might call them comments, but it's just stuff you put, the program, the computer doesn't run. It's just some documentation you put into your code to help others understand it or your future self. Comments are a form of that documentation. So again, your language might have done comments differently, but right, those are ways that you can put into code that, of comments so you don't, the computer doesn't run that code, so you can make notes in your coding. So we will see some program documentation and have some questions about that as well. Here is the error section, right? We said we were going to talk about identifying errors today, so it's important to know the different types of errors. So we have 4 different types here. Logic error is a mistake in the algorithm. So say you did addition instead of when you wanted to do multiplication, and the program runs great, but if you don't run it and check it, then you won't notice that you screwed up the logic somewhere. So logic error just doesn't behave the way it's supposed to after it runs, or it doesn't do what's expected. A syntax error is a mistake when the program rules are not followed. So the rules of whatever language it is you learn, some languages require the semicolon or a semicolon at the end of a line, or you have to have certain punctuations or indentation or curly braces. Those are syntax errors, and so those don't let your program run. You have to fix those before. A runtime error is a mistake the program that occurs during the execution of a program. Programming languages define their own runtime errors. So depending on your language, it would be a little different what a runtime error, but say your program, you enter some values and it ends up dividing by 0. That's going to be a runtime error in most languages. So it runs and it seems to work, but then it hits this major error and it won't run anymore. It stops the program. So not the same as a logic error, because the logic error runs, but then the code doesn't do what you want it to do.
And then an overflow error is another one that will stop your code. An overflow error that occurs when a computer attempts to handle a number that is outside of its range of values. While computers are fast and can do things and can hold a lot of data these days, and we even usually carry that computer around in our pocket. Yep, our phone, it's a computer and stores a ton of data, but sometimes you put too many pictures or take too many pictures and that phone can't hold anymore. That's basically an overflow. So there is a limit to what your computer can do. And certain languages and certain things we work with only have a certain limit that they can hold of data they can hold. So when a program's running, it may hit that overflow error. So that's some of the essential knowledge from Big Idea 1. It's a little vocabulary there, but again, in this case, this vocabulary is important and helpful as we begin to look at multiple choice questions over these topics. Again, we'll see some coding examples and we'll analyze some code, but a lot of times it may involve some of this terminology, and it's important to review this essential knowledge before we move on to our examples. So now we're ready for that first example of a multiple choice question that we are going to work through, and we are going to see some of that code right away. So here's the first example question. On these and the practice ones later, if you would like to not see or hear me talk about it, you're welcome to pause. You see the pause symbol there on the slide. You're welcome to pause the video so that you can work out the problem and not hear me talk through it yet. And I'll eventually show the answer as well. So if you'd like to wait for that answer to show up, you're welcome to pause the video and catch the rest of it after this. So first example question, the following code segment is intended to set max equal to the maximum value among the integer variables x, y, and z. The code segment does not work as intended in all cases. So you see there, we have if x is greater than y and x is greater than z, then we say the max is x. Then we have another if statement. If y is greater than x and y is greater than z, then the max is y, and then else max is z. So there's your code segment using this pseudocode. So hopefully you can understand. It's pretty simple. Most languages have a similar syntax there. Which of the following initial values for x, y, and z can be used to show that the code segment does not work as intended? So we know the code doesn't work. So since you know that immediately, what I would do for this question is kind of look at the code and think about how maybe I would code it differently and see if you can understand or figure out the code yourself. If you're struggling with figuring out what's wrong with the code to start with, let's take a look at some of the values. It's a great help with this question. There's values for x, y, and z. So you can almost kind of work reverse and plug answers in. So in this case, I'm going to go ahead and highlight that obviously we know as humans where the max is. So in this first answer, A, the max is at z. B, the max is y. C, the max is also y. And D, the max is x. So we can see that, quickly view that. So obviously that's going to play a part in which one's going to work correct or which one's going to make it not work. So so we need to make sure we have one that shows it not work as intended. So obviously when I try A, I should be getting Z, the max should be Z, which is 3. So if I run A, so X is not greater than Y. So that already stops right there. I know X is not greater than Y, that if won't happen. Now here's the important part of this code. The next one is an if, so I have to check that if too. And I check that if and I say, is y greater than x? Yes, it is. Then, and is y greater than z? Nope, that's not true. So now it goes to the bottom and says, okay, else the max is z. Well, that's the case. That's true in this case. So that works. So what we're trying to find is which one of these other ones doesn't work as intended, where the answer isn't what it's supposed to be. So that one, it wasn't x, it wasn't y, and we got to the z. So now we have 2 where the max is y. So both of these should return y, or tell us that the max is y. So the first one is x greater than y. Nope, so that if doesn't run. But then there's another if, so we have to check it. So now, is y greater than x? Sure is. And is y greater than z? Sure is. So max is y. Okay, that seems to work as intended. Now, we have it, example C. On example C, we have x is 2, y is 3, z is 1. So is x greater than y? Nope, it's not. So we already know that this one won't work. So we go to the second if. Is y greater than x? Yes, it is. And is y greater than z? Yes, it is. So it will say the max is y. Again, it worked. So those have done well. Now here, obviously in this case, I think the answer is D, but we should check, right? And if you have a better inkling or you can kind of see what's happening or you don't need to check them all, maybe, and some people say it's a good idea to start from the last one up. But it just doesn't, you never know which one will be the answer. So here, when we take x and we say is x greater than y, that's true. And then is x greater than z? Yep, that's true. So then we set max to y. But hold on, this is another if. The computer will process every line. In an if else, remember only one happens, but this is another whole if statement. So this gets processed. So even though we've set max to x right now, this happens. Is y greater than x? That is not true. Y is not greater than x. So this is false. The computer says, oh, I need to do the else, and it sets the max to z. So the max is set to z, which is 1. That is not right. So again, remember, most times when you have a multiple if-else statements, they should be if, and then an else if would solve the problem here. But all we needed to do was find the one that didn't work, the one that showed that the code didn't work. And in this case, that answer is D. So answer D, x is the max, but this code sets the max to z, which is 1. So that won't work. All right, hopefully that was a good example to see the code that we're going to work with and kind of step through and make sure we're doing all right. We're going to move on to another example question. And again, anytime you can pause the video to kind of catch up or make sure you understand. This one, we have a procedure. This time, the code is written in text instead of blocks. The following procedure is intended to return the number of times the value val appears in the list MyList. The procedure does not work as intended. Again, remember, looking for errors this time. That's what this first big idea is about. Which of the following changes can be made so the procedure will work as intended? So the code's a little smaller there on the left, but hopefully you can see each of the lines. So our procedure is called count num occurrences. So that may help think about what the procedure should do. And then you can see that we have a for each in there. So you may not have seen a for each in your language, but a for each just says go through each item in the list. So for each item in the list, we're seeing if the item is equal to val. If it is, we count, and then we return count. So we have count set to 0, count gets the value of count plus 1, and then we return it. So we're looking for to see here will help to make this code work as intended. So line 6, it says changing line 6 to if item is equal to count. So that's one of our options. Changing line 6 to if MyList bracket item is equal to val. And next up, answer C, moving the statement in line 5 so that it appears between lines 2 and 3. And then moving the statement in line 11 so that it appears between lines 9 and 10. So we know we're trying to count the number of times val appears in the list. So I think my if seems to be pretty good. Again, a for each just says for each item in the list. You don't have to worry about the indexes of the list. So in this case, I think my if is good. So I'm going to eliminate A and B. I'm going to say, nope, those aren't my answers. So now I'm going to think about moving my lines. So my for each starts on line 3. For each, remember, for each item in the list, that's repetition, that's iteration. So that loop is going to happen over and over again. And the first line in the loop, I set count to 0. So every time my loop happens, count 0, count 0, count 0. How am I going to count the val? How many times val appears if I said count to 0 every time my loop happens. So basically I'm resetting count to 0 so I can't keep track of how many times val occurs in the list. So that is my problem with this code. So I need to move that line. So a return, right? Return should be at the end. So if I'm looking at answer D, I don't think I need to move the return, which is what line 11 is. So C is my answer. Moving the statement in line 5 so that it appears between lines 2 and 3 is what I need to do. So that count is 0 before the loop starts. Then I go through every item in the list, and every time I find that val, I count it. So again, looking for errors, some of you may be able to spot it really quick, but it's good to eliminate choices and think about what the program was supposed to do as the directions stated. If you need to underline or circle anything in the question, that's a great thing to do because you will be able to write on your test booklet. So keep that in mind as you're working through questions that may have a lot of words. Highlight, underline, look for the key facts here. So, right, this procedure is intended to return the number of times val appears in the list. So keep that in mind as you're working through the problem. All right, we are ready for some practice. True practice here. These are some other questions. We'll have more practice on similar questions or other ideas now. Again, if you would like to wait for the answer or make sure you don't hear the answer until you've come up with it, you can always pause the video. So we're going to talk about all kinds of stuff with creative development. We're going to see tons of questions here that help you through that material. So again, some questions may be a little wordy as this one is. So keep that in mind and highlight and underline. Well, you can't highlight on the exam. You only have pencil, but you underline or circle things if you need to. Here's our question. A company that develops mobile applications wants to involve users in the software development process. Which of the following best explains the benefit in having users participate? So we have 4 options. Users can identify and correct errors they encounter when using released versions of the software. Remember, we're talking about users here. I don't know if you, most of us are users on our phones and on our computers, and I don't think I usually identify and correct errors when I'm using something. So don't think that one's the answer right now. Users can review the algorithms used in the software to help improve their efficiency. Again, talking about users here, until this class, you may not even know what an algorithm was. So again, a user may not really know that. So I'm kind of thinking that one's not the answer right now either. Answer C. Users can provide documentation for program code at the end of the software development process. Again, we talked about at the beginning during our vocab review that documentation is something we put into our code and it's good to have, but it's not really for the user again. We are the programmer, we are the developer, and so we're talking about users here, and so users will not be putting that documentation in there. So I definitely am marking out answer C. So I'm looking like I got to answer D again. Let's see what that one is. Users can provide feedback that can be used to incorporate a variety of perspectives into the software. Right. It's so important to involve your users in the process so you can know what they think and, right, get a variety of perspectives. It's hard for you individually to know what other people are going to think about software and make sure that you include their perspectives. It's not always easy for us to think about how someone of a different age or a different background will view the code. So that is a great way to involve users in the software development process. And so that is our answer, answer D. So again, this hits on one of the topics in the big idea 1. So that's why we're taking a look at this software development process. Practice question number 2. Here we are, we got some more code we're looking at, the block code, pseudocode. Again, earlier when we saw that for each, or when you see this, if you have any trouble or you're not sure what this code means, the arrows, if you're not sure what the arrows mean, you can use that exam reference sheet. Again, it's more than a sheet, it's actually a packet. Can find it on the website and use that reference sheet. If you haven't saved it yet, you might want to do that or print it out. Maybe your teacher has printed it out for you so you can reference it now. So if you have any trouble understanding the code, that is definitely something you want to take a look at. So in this question, in the following procedure, assume that the parameter x is an integer. Which of the following best describes the behavior of the procedure? So the procedure is a mystery. Well, they like to name them like that. So mystery, and then we see we have a parameter x. And then in our procedure, y is assigned the value of x less than 0. Now, x less than 0, that's a Boolean expression that will result in true or false. So y is going to be assigned a value of true or false. So then we can say if y. So if y is true, the display will happen. If y is false, the display won't happen. And if you take a look at the answers here, here's my tip on this one. Look for what is different in the answers. In this case, if x is negative, if x is negative, if x is negative, if x is negative, every question says if x is negative. So that doesn't play a part in how you decide your answer. So you're not worried about that. So look for what's different. So when I look for what's different, the first answer says it displays nothing if x is negative. The second one says it displays nothing if x is negative. Then we have it displays true if x is negative. It displays true if x is negative. So there's two, A and B and C and D. We have two sets there. So based on what I saw, if y, display y. So if y is true, it's going to display something. There is no else here. So if y is not true, it will do nothing. So we need that nothing involved. So that can help me to eliminate answers. So if y, that says if true, display y, which is true. So will this procedure ever display false? Nope. So there is where I can see the differences in my answers too. Displays false, displays true. So right now I can eliminate the two that say displays false otherwise, because there is no otherwise, there is no else. So I'm going to eliminate B and D right now. Eliminate B and D, and I know it has to be A or C. And so the first one says displays nothing if x is negative. And again, we're assigning x less than 0 to y. X less than 0 means x is negative. So it won't display nothing because x less than 0 makes that true, which makes y true, which will display true. And so our answer here is C. It will display true if x is negative and displays nothing otherwise. Again, some of you may be really good at code and this question isn't a problem. But if you're struggling with understanding this code, a good way to do this problem is look for the difference in the answers, look what's different, eliminate choices, eliminate things that you know cannot be the case. All right, practice question number 3. Again, another wordy one. So if you are, when you're taking the exam, feel free to mark out, underline, whatever you need to do. 3 students in different locations are collaborating on the development of an application. Which of the following strategies is least likely to facilitate collaboration among the students? We have 4 choices here, and again, that least, it's in all caps, but you may want to highlight, right, we're looking for the one that's least likely to facilitate collaboration. I know you've collaborated in your classes this year. It's a big push in this class, and you've worked with your classmates, right? So which strategy would not help you to in the software development process or development of an application? So here are our options. Having all 3 students participate in frequent video chat sessions to discuss ideas about the project and to provide feedback on work done so far. So again, remember, we're looking for least likely. That sounds like a pretty good idea. Having all 3 students use an online shared folder to contribute and discuss components to be considered for use in the application. Again, that sounds like a pretty good idea. Both these are ways that we can share with other people. Just here, we have a shared folder. Sometimes we may do a video chat. So 2 different ways to share and work with others. C, having all 3 students write code independently and then having one student combine the code into a program. That doesn't sound very collaboratively if we're working independently and then one person is putting it all together. So that sounds like it's not a very good option for collaboration, but let's check answer D. Having all 3 students work in a shared document that each can edit to provide comments on the work in progress. Again, just another way for you to collaborate. Again, in today's day and age, we may not be in person, but we can sure use our digital tools to collaborate. And A, B, and D would be great options to work with others, where C does not allow for that collaboration. And so it is the least likely to facilitate working with others and getting everyone's feedback to have a program that has different perspectives. So that is your answer, answer C. Practice question number 4. This one's a little lengthy. It talks about this app here, and you may have some questions where you see something like this and there's a couple questions. Not the reading passage, but the reading passage will have 5 questions about it. But there are some where you might see a question, oh, here we talk about this app, and we may have a couple questions about it. But little lengthy, again, look for key terms, underline things if you have to when reading this on your own on the actual exam. So here's our mobile app, Dine Out Helper. Dine Out Helper is a mobile application that people can use to select a restaurant for a group meal. Each user creates a profile with a unique username and a list of food allergies or dietary restrictions. Each user can then build a contact list of other users of the app. A user who is organizing a meal with a group selects all the members of the group from the user's contact list. So they basically select all the friends. The application then recommends one or more nearby restaurants based on whether the restaurant can accommodate all of the group members' allergies and dietary restrictions. Suppose that Alejandra is using Dine Out Helper to organize a meal with Brandon and Cynthia. Which of the following data are needed for Dine Out Helper to recommend a restaurant for the group? So we have 3 options. These questions are common on the AP exam. You have a 1, a 2, a 3, and then your choices are like 1 and 2 only, 1 and 3 only. So these type of questions come up a lot. So it's important to make sure we take a look and understand this format. So here are options. Each group member's list of food allergies or dietary restrictions, Alejandra's geographic location, the usernames of the people on Brandon and Cynthia's contact lists. So in this case, remember, let's go back to what the app is doing. So remember that Alejandra is organizing the meal. So the app says a user who is organizing a meal with a group selects the members. So she selected Brandon and Cynthia. And then the application recommends one or more nearby restaurants based on the restaurants that can accommodate her group's allergies and dietary restrictions. So in order to determine ones nearby, that location I think is going to be important. So to find ones nearby, we need Alejandra's geographic location. So I know I need 2. So that helps me to eliminate answer B. And then obviously, if we're going to recommend restaurants with allergies and dietary restrictions, then we need to know those allergies and dietary restrictions of the whole group. So it looks like I'm going to need number 1 too. So that means I can eliminate C. So I'm down to, okay, is it 1 and 2 only, or is it 1, 2, and 3? So 3 is the usernames of the people in Brandon and Cynthia's contact lists. Well, Alejandra's organizing this, so I don't think we need the usernames of people in their lists. So I don't think that's needed to determine what we need for this situation. So that is going to be our answer. Answer A, 1 and 2 only. All right, we have a few more questions to go. Hopefully this is helping you out, taking a look at these multiple choice questions and going through each one, kind of analyzing and thinking about tips you can use to answer these questions on the exam. Back to a coding one. So here we have a nice big code segment with a repeat until. Again, if you're not familiar with this repeat until, then you'll want to pull out that exam reference sheet and kind of take a look at it to make sure you feel comfortable with this repeat until. So here is what we have. A student wrote the following code segment, which displays true if the list, my list, contains any duplicate values and displays false otherwise. So we're looking for duplicates. The code segment compares pairs of list elements. Setting contains duplicates to true if any two elements are found to be equal in value. Which of the following best describes the behavior of how pairs of elements are compared? So here we have a repeat until. We have two repeat untils. We have nested loops here, repeat, inside of each other. So let's take a look at the options here and think about the code segment after. The code segment iterates through my list, comparing each element to all other elements in the list. The code segment iterates through my list, comparing each element to all subsequent elements in the list. The code segment iterates through my list,
comparing each element to the element that immediately follows it in the list. The code segment iterates through my list,
comparing each element to the element that immediately precedes it in the list. So we read the options. You might think about the one that sounds the best for our situation, but let's look at the code a little bit. So the first one, repeat until j is greater than the list of the my length minus 1. So that looks like j is going to go through everything. We started j at 1. That's important to know, and we will cover this again in another AP Live. But again, on that exam reference sheet, you want to take a look at the lists start at 1. Your programming language may have been different. Other programming languages, some programming languages, when you have a list, the index starts at 0. Some programming languages start at 1, and for the AP exam, they start at 1. So we'll cover this again later in another AP Live when we talk about lists. But again, you may want to go ahead and make note of that. So that's why J is set to 1. And then we keep repeating until we get to the end of the list. So then we have K. K is set to 1 more than J. Then in my if, it says, okay, we're going to compare my list J with my list K. So in this case, we've started 1 after. But then that loop also continues. If you notice in the code, we are adding 1 to J and K. So K in the inner loop, J in before the outer loop starts over. So we have set K to 1, and then the first time through, or J to 1, K would be set to 2, right? And then it keeps looping until it gets to the end of the list. So when we look at the element at spot 1, we would then, K would be 2, we check it, and then we move on to 3, move on to 4. So we're taking a look at it, and then the next time we loop back around, J would move on. So J would move on to 2, K would start at 3, right? Because this line right here inside the first one, J plus 1, so K would be 1 after J. So looking at the code and after reading those answers, we should be able to realize and think about what we want to do if we want to look for duplicates, right? If we want to look for duplicates, we want to take this one and compare it to every other one. If we compared it to itself, we would think there was a duplicate. So that is why we're making K J plus 1 so that we check the one after it and all subsequent elements after it. So that is going to be your answer, answer B. Again, if this code was confusing, please reference the exam reference sheet. And remember, on the AP exam, list indexes will start at the value of 1 for the AP pseudocode. All right, a few more practice questions to go. Here we have some more code. We have a procedure this time, calculate. In the following procedure, the parameters x and y are integers. Which of the following is the most appropriate documentation to appear with the calculate procedure? Again, we talked about documentation earlier in the vocab. So here we are, we have a procedure. We need to see what it's doing so we can say what documentation should be there. So when I look at the procedure, it's called calculate. It has a variable called result, which the value, the sum of x and y is stored in. Then we take that result, divide it by x, and assign it to result, and then we display the result. So Remember that it does the x plus y, puts that into result, and then it'll take that value and divide it by x. So in this case, when I use my earlier tip, what is the difference in these answers? When I look at my 4 answer choices, I notice the difference is where the parentheses are. Because the rest of the question is pretty much the same. Displays the value of whatever the math expression is. The value of the parameter x must not be 0. Every one of them, except for the last one, says the value of a variable x, y must be 0. The sum of x and y must not be 0. So we do need to take a look at that, but let's worry about the first part first. Displays the value of, and we have a mathematical expression. Notice that A and B have the parentheses on the division, C and D have the parentheses on the x plus y. In this code, x plus y happens, gets assigned to result, and then that result is divided by x. So the x plus y happens first. So with your math, and in computer science, the parentheses happen first. So we know the answer is C or D. We don't even have to worry about the other sentence up here because we know it has to be C or D now. So then the difference is the rest of it. The value of the parameter x must not be 0. And then D, the sum of the parameters x and y must not be 0. What are we doing in this procedure? We're dividing by x. So if x is 0, that's not cool. That doesn't work. Can't do that math. So that is what we would want to put for documentation. So someone using this procedure knows they should not send a value for this procedure where x is 0, and it tells them what it does. So that's your correct documentation is C. Question 7. Again, if you need to, you can pause the videos before I tell the answers. Here we have another text code segment. In the following code segment, score and penalty are initially positive integers. The code segment is intended to reduce the value of score by penalty. So both of them are positive. We're going to reduce the score by the penalty.
However, if doing so would cause score to be negative, score should be assigned the value 0. So we don't want negatives. We want to take the penalty, but we don't want to go below 0. For example, if score is 20 and the penalty is 5, the code segment should set score to 15. So 20 minus 5, we set it to 15. If score is 20 and the penalty is 30, score should be set to 0. 20 minus 30 is negative 10. No, we don't want that. Set it to 0. The code segment does not work as intended. Oh, how did you know? This is the error section. Which of the following changes can be made so that the code segment works as intended? Changing line 1 to if score less than 0. Changing line 1 to if score plus penalty less than 0. Changing line 7 to score to set the score to score plus penalty. And interchanging lines 3 and 7. So let's look at the code. Right now it says if score minus penalty is less than 0. So that's going to take the score, subtract the penalty, and see if that's negative. If it's negative, then it's going to set the score to that subtraction. That doesn't seem right. So right, if I take score minus penalty, so plug the values in if you need to right here. You can write on your test. So plug in 20 and 30. That would make negative 10. That's less than 0. And then it would do score set to that. It would set score to negative 10. That's not what we wanted. So it sounds like we have a little problem here. Really, we want to change those lines. If this is true, like we have with 20 and 30, if this is negative 10, then we want to set it to 0. So I think answer D is going to help us switch because my if seems right. I'm trying to see if score minus penalty gives me a value less than 0. But if that's the case, then I want to set it to 0. So D, if I just trade what's inside my if and else, my code's up and running and we'll do what is intended here. All right, practice question 8. The following procedure, more text coding here, is intended to return true if the list of numbers in my list contains only positive numbers and is intended to return false otherwise. The procedure does not work as intended. Oh, here it is again. For which of the following contents of my list does the procedure not return the intended result? This is, again, very common questions here of code not working and how do we see what should we do to test to make sure our code's not working and how can we fix some code. So here we are, procedure all positives. It's been sent a list as a parameter. So we are going through the list, and if you can recognize maybe what the code's doing wrong, that can help you to determine the answers. Again, we are trying to return true if they are all positive and return false otherwise. So we have one answer where they're all positive. So D has an answer where they're all positive. All the others have negatives, so they should return false. So let's take a look here. So it should return true if they're all positive. So here we go through my list, and again, indexes start at 1. And so this takes an element of a list and see if it's greater than 0. So when I'm looking here at any of my answers, negative, 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 so this won't happen. Here, 1 is greater than 0, it will return true. Now that seems to be pretty quick because it returns immediately and it didn't even check these others. So it works, but I don't think that's quite right, is it? So then if we look at if we go to spot 2, okay, -2 is not greater than 0, so it just keeps going through the list. -1 isn't, 0 is not greater than 0, 2 is greater, it wouldn't even get here because it would have already returned. So we know D isn't really, it's still the correct answer, even though it seems it returned early. And then if I look here, okay, -1, not greater than 0. So the loop would end and that one would return false. B, 0 is not greater than 0. Okay, loop would end, it returns false. But C, 1 is greater than 0. So as we went through this list, we found a positive and it's returning early here. 1 is greater than 0, so it returns true. So we have a little problem in our code where it returns early here. And if we have one value that's true and the others are not, it returns true, even though it shouldn't. So example C shows you that it's not giving the result. They're not all positive there. So that is not what it should do. These others return false, even though the code's incorrect, and this one still returns true. But the answer C is the one that really shows you that doesn't work as intended. All right, question 9. A homework assignment consists of 10 questions. The assignment is graded as follows. If you get 9 or 10 correct, you get a check plus. If you get 7 or 8, it's a check. If you only get under 7 correct, it's a check minus. So let num correct represent the number of correct answers for a particular student. The following code segment is intended to display the appropriate grade based on num correct. The code segment does not work as intended in all cases. For which of the following values of num correct does the code segment not display the intended grade? Select 2 answers. Here, I wanted to make sure you saw one of these questions. It's a multi-select. So you will need to mark 2 answers and you need to get both answers correct in order for it to be counted correct on the exam. So we need 2 answers that show that this code segment does not work as intended. So the best thing here is just to plug them in. 9 is greater than 7. 9 is greater than or equal to 9. It'll say check plus. That matches my chart. Next, I'm going to go to B. 8 is greater than 7. It's not greater than or equal to 9. It says else check minus. 8's not a check minus. Okay, mark that off. That's one of my answers. Now I'm going to try 7. 7 is not greater than 7. So this is not true. It goes to the else. It displays check. Yep, that needs to happen for 7. Next up, we are going to try 6. And 6 is not greater than 7. So that one doesn't run. It goes to the else and it displays check. But a 6 is under 7, so it should be displaying check minus. So therefore, these 2 didn't work. So those are your 2 answers. Again, you will need to mark 2 answers. And those 2, in this case, pretty easy just to try the numbers. All right, those are all of our practice questions. We are about to wrap this up, but First, I want to give you a Create PT tip of the day. Again, it's due very soon. So here's a tip to make sure you're doing well on it. So be sure your program has a purpose. Again, you're going to have to explain that purpose on the written responses. The definition for purpose from the College Board is the problem being solved or the creative interest being pursued through your program. Make sure that you answer. Also, another tip is to answer the written prompts as you go, so you're not overwhelmed at the end. That may be a little late for that tip, but if you haven't done them, maybe do some coding, try to answer, or don't just do all the written responses at the end. If you haven't done any yet, I'd say you better get started on them. And again, talk about the purpose. Why did you make the program? Is it solving a problem? Why were you interested in it? So those are your Create PT tips of the day. There is a link to the folder with some more resources for the Create PT if needed. You can check that out on your own. All right, so what should we take away from this AP Live? So here we have, right, the exam consists of 70 multiple choice questions. You get 120 minutes or 2 hours to complete it. Here are some of the enduring understandings. Incorporating multiple perspectives through collaboration improves computing innovations as they are developed. Developers create and innovate using an iterative design process that is user-focused, that incorporates implementation feedback cycles, and that leaves ample room for experimentation and risk-taking, which often leads to errors that we have to fix, which is what you saw in a lot of our questions today. Tomorrow, you can join Sandy Chaika for practice with the reading practice questions, like on the exam, as well as the topics of legal and ethical concerns, computing bias, and beneficial and harmful effects. Thank you so much for joining me, and I will see you in 2 days.